Hello again and welcome back, all my favorite coder cats and coder kittens. As usual, this is Becca going by Nightcat or Nightcat's Meow most places online, and I am here again to talk to you about Linden scripting language. Now, I got a few specific comments last week about the raycasting being not the clearest thing in the world. So we're going to go over a little bit about how you can detect things with sensors or raycast, and then break down in a little more detail how raycast work. This is kind of the sort of thing I do on Decoded, but it seemed appropriate to deal with this here. And hello, Lily. Lily is not happy that I'm making a video right now instead of paying attention to her fuzzy little butt, but y'all need my lovin' too. So here we go. If you're using a normal sensor, you can think of it as starting out like a sphere. And then you adjust the dimensions. I'll actually pull up the command for a sensor on the wiki. There it is in the sensor repeat. You get a distance and then a multiplier by pi. So this brought up for the sensor event handler. The event handler is what deals with the information provided from the sensor repeat. So the sensor repeat is actually the one we really need. Come on. Go, Link. Work for me. Actually, sensor itself would have done too. LL sensor. Come to think of it, would have worked just fine too. Alright. You have here, it gives the name, key ID, type, radius, and arc. Radius and arc are the key parts that are important to this discussion, but we'll go over everything. It's capable of scanning for specific things. You can scan for a specific name, you can scan for a key ID that will look for a group. As it explains here, the key can be for a group, a specific avatar, a specific object, anything in the region. And then the types are agent, which is an avatar, agent by legacy name, agent by username. So basically, your login name versus your regular name. Active, which means it's actually not a passive object. Passive is just your normal, I've resed a cube, it just sits there, it's passive. So active can be physics or script, and then scripted. So you have all that right there. It actually defines right here which will actually trigger. Scripted will trigger under active or scripted. Not scripted might trigger under active if it has physical movement. If it's non-physical, it will be passive. Just a little matrix that explains all of that. But back up to here are the parts we actually need to worry about. Radius, distance from the center, and arc, the angle between the local x-axis of the prim detectable objects from 0 to pi. So what that really means is that you designate on a sphere with a multiplier of pi, and as you shrink that radius, you get a sensor that looks more like these shapes that I'm creating here. Scanning outward like that. Larger gives you a wider scan area until you start to reach behind and become a proper sphere. The difference is a raycast does not work like that. A raycast would work more like this. It would just send a single detection beam outward all the way to its maximum distance. So what we did there, when I used a raycast instead of a sensor, is that instead of defining I could have defined a very narrow sensor going forward, and I could have gotten very similar results, but it would have just continued to expand as it went. This is a pure line of sight. When I go into mouse look, it will specifically give me only what I actively aim at. Oops. Reset that. Didn't actually detect the thing there. So let's go back in, turn that back on. In order to cut down on prim weight, I do a lot of jiggery pokery with stuff in the loft, so it's not actually the best place to test this. There, we got it. It detects the object. Raycast works really, really well in mouse look simply because you will get exactly what's at your center point, exactly what's in that little reticle on my screen. So to better look at what I did and break down the raycast itself, I started with and I should bring up the cast ray so I can go over what each of these options are. You get the vector start, the vector end, and a list of options. It's comparatively simple because you only have the 3 things you need to cast it. So to start, I used get camera position. So that's where it started. If I'm in mouse look, the camera position is going to be wherever my point of view is. And then start plus 1,000 meters, x-axis, but this part is multiplied by get camera rotation. What doing that does is it takes that and it angles it to match wherever the camera is pointing. If I did not have the times get camera rotation, it would fire 1,000 meters on the x-axis of the sim as opposed to the x-axis of my camera. So doing this is a simple and easier way to simply shoot 1,000 meters forward, and probably a lot more than I really need. I probably don't need to have it be 1,000 meters. And then it filters by these settings. The filters are actually a part you can tweak and play around with, but it will give you an explanation of them come down here. You have raycast reject types with further filter used to ignore specific types of objects and avatars. So we have reject land, and then reject, yeah, the only one we have reject is to reject land. This would mean if I was on the bottom of the sim and dealing with the sculptable Linden land, these 2 flags would tell it to ignore that. Then I have data flags, and that just tells it things to get. Raycast data flags. Get root key. So what that means is if I had a multiple object situation, or a multiple part object, if I had a whole bunch of other cubes attached to that cube I just shot it at, it would automatically focus its data on the root of that, not on the keys of the individual pieces, but the key of the root object. Raycast max hits 1. What that means is that it gets the first thing and then it stops. If I didn't have that, it would keep processing things until it reached the maximum of its distance. And then raycast detect phantom equals true. All that actually does is that if I turned this phantom like so, it now just fell through my world. It will self-delete when it hits the bottom of the simulation. It will fall infinitely until it hits the bottom, and then it will self-delete because it will quote-unquote have gone off-world. So there were people that wondered a little more about the raycasting and why I use it and what all the settings were, and this hopefully makes it make a little bit more sense what each of those was all about. So with that settled, I will actually go through and talk about using a sensor to gather the same information in next week's video, so that you can see an alternative method of getting that data. So, until then, sorry for the occasional interruptions by the fuzzy lily, but I hope to see you next week. Until then, good day, good luck, good week, happy coding, meow.